Good morning, good afternoon, good night, good day. You are listening to Sandile Mnai, all the way from South Africa. I'm presenting to you today an opinion, a proposition of how I think we should advance our data-driven automation frameworks in the art of software testing. I have 10 years experience in the field, so I've made this observation as far as I've come, and I'm looking to share what I think I've learned. And perhaps if this makes sense or is sensible to whomever may be listening to this talk, I hope you'll find it useful and it'll be of help to you and your team from this point on. Now, I make this talk and I've had this particular concern which came organically when I was, when I'm working through software automation. I find that I get very upset, not so much upset, rather disappointed when a major defect appears in the software that I have been hands-on testing myself and the colleagues for an extended period of time, only to find that we've missed a critical defect, which you'll find sometimes perhaps there is no way of catching all defects 100%. But in any case, this concern has developed into a thought, which is this proposition that I believe we should perhaps move a step further from just having static input data in our data-driven automation framework, whether it be data-driven, in your data driving of it, whether you'd be using keywords or whatsoever format that you choose. I believe we can advance this art to the next level, which is semi-static, dynamic if you will. But the dynamicity here speaks to the attributes of the software that do not particularly speak to the heart of this particular use case. Now you may say, well, what's the point of that? Well, let me get to it. Say you have a software feature, certain business function that you are testing. In this particular use case, you are testing the output, what will come out for a certain range of values, these ones in blue, and your API, for an example, takes 12 fields, but it's only the 5 that are necessary to meet certain qualifiers to make the test a success, and they should always remain the same for the test to always give a positive output. So we can put whatever values for these other ones, maybe leave them blank, or perhaps if they're mandatory, we can just put some rubber stamp, values that shouldn't necessarily influence the behavior of this use case. Okay. Now, in real applications, you'll know we generally have more than one database or data set or more than one service that interacts, particularly in big applications like in your banking systems. We'll have more than one that the APIs will work together to, will interact. So you have external services that aren't necessarily your main focus, but play a critical role. That is an extended talk, which, if you will begin to imagine it, as I have simplified it to this use case, you can see what I'm trying to translate this to on a bigger scheme. But I'm going to simplify it for now for just the purposes of simplification and understanding, and purely to translate the message that I'm trying to get across here. So the first 5 fields, it's a banking application for an example. You need an active account number, so a valid ID number, for example, identifier for the user, maybe a unique ID, a numeric value. You may want this particular personnel to have a sufficient balance to qualify for a certain feature, which is what you're testing. Perhaps it needs to be between certain age ranges, a certain age range. and some other some other attributes that you may just need to qualify the scenario. And the rest of the parameters in the API don't necessarily influence, or should not, presumably. Now it's not presumably, because obviously we read the requirement specification, and they should not at all, at least for now. But you'll know that in software evolves, features come up every other day, new features, new functionalities get implemented. And that makes this static way of testing very stagnant, in a way that while it will give us the results that we want for this particular scenario, we miss the opportunity of using these values. It's almost like building an automation framework that has its own intelligence, that it can vary certain values and try certain things, and should the behavior change, then we should be concerned. But it should not, ideally. But we know that in real life scenarios, over time, it generally will. So the idea here is that while we keep these 5 static, we should not keep the rest of these parameters static. We should allow the system to vary the rest of them, as proposed in this part of the talk, where you are seeing these ones gray, resembling or symbolizing that they are not necessarily the key fields that we are testing here, but they are dynamic in shape, size, and form, because we intend to have them changing over time, because it shouldn't matter, right? So we can let them dynamically change, and if they do influence the behavior of the system by them changing, we will not only learn the behavior of our system, which is now the system teaching us about itself, but we are maybe catching a defect, or we may be exposing functionality that we may actually desire, and say, well, look, you see. So there's numerous benefits of having this particular approach as to this static formation. Now you could achieve this in Excel by writing macros to vary these fields, but that would be a lot of work. In fact, I personally am of the opinion that putting your data-driven input in an Excel field is rather old. I think software has evolved enough. I mean, I imagine that the reason the Excel was opted, or was the option to begin with, was because it was easy, simple to store the data. But think about now. It's no longer the case. I mean, it's still simple. But is it simpler really? For example, if you're using Java, is it simpler than just writing a simple server that can host a database for your input data? Which does not only mean that your data can now be more dynamic, but it's living data, which is what production system is. And you will find a lot of defects getting missed because of the data just being static. Static, kind of dead. Dynamic, it's alive. It's alive. So when you fetch your data from the database in a living scenario, which I am proposing, you write a simple server. And I mean, consider also that these days we are moving into Docker. We are Dockerizing, containerizing our services. So to now have Excel and Windows installed, I mean, that's taking space, memory. It's not such a big deal. We have a lot of memory, but then again, it's not as lean. Startup time is not as fast as we want it to be. Scaling up, scaling down. So how about, but our automation does not live in production. True. But even then, what is the benefit of Excel? I find more limitations than benefits. It's not as hard to write a service that stores data anymore. So why do we keep sticking to this? Because it's just a legacy tendency that we have not reviewed. And I offer the opportunity to review it. I say, let's do away with the Excel and the static inputs for the rest of the fields. Let's make them dynamic. So in your database, fix the 5, but as you will have a service or script that creates the data on a frequent basis, have it create dynamic values for the rest of them, so that the system will just be trying out new different combinations every time that you may not always think about. But the minute you find a red alarm, you can go back and analyze and learn. Before we learn in production, it is much more expensive to learn in production. Rather learn the system pre-production. This is really the core of this talk, but it obviously entails a whole lot more to it. See, I look at automation or software quality or testing. I try to look at the human body, and I look at the software, and I think to myself, well, the human is a pretty good application. If you look at the human body, as we are a production system, but we also have tests that are running always inside of us. You touch something hot, you get feedback immediately that something is wrong. Now, this is an extended part of this talk, which I don't want to indulge in so much. But this living, alive framework, which lives in a database, if it's a leap year, the data is there living through the leap year. If the database, new tables are created, new columns are added, new values are added in the database, we are adding new values to an existing database that is living for our automation framework, just as production. How many issues do you find during migration? How difficult does it become? Going from a legacy system to a future one. As an example, some fields didn't exist. Some fields had values that we no longer allow. How do we create automation that can listen and pick all of these things up? First and foremost, it has to be alive. It has to live just as production. Well, you say, well, the cost of that is pretty intense. I mean, I don't think so. But then again, which cost would you rather pay? Production defects? A blocker? Or would you rather learn beforehand and run a smooth automation, a smooth production system? Now, this is a proposition which I believe in its beginning will rather be challenging for perhaps some people. I don't think that it should be in any case, but probably maybe, because now you're going to say, well, how do we have confidence in our automation framework when we have varying values? Well, they shouldn't matter, right? So we should have the confidence. And if we find that at every point in time we are not getting confidence in our automation because of, oh no, it's because, it means we don't understand our system full and well enough. So I think it perhaps may be costly in the beginning, but over time as we learn and tweak and change and perfect it, it certainly seems like the way to go to me. But I will leave you to be the judge of that, and I will appreciate your comments on what you think about this talk, this proposition. Perhaps you may have other ideas. Perhaps you may think that it will not work. Please don't keep them to yourself. Share. Some people may read them, and we may all gain value and grow in the community and the art of quality software testing. My name is Sandile. Thank you very much, and have a blessed day further.